Hello, everybody. All right, so today's lesson 5.5 on page 219 of your fourth grade book, we'll be talking about prime and composite numbers. Okay, and so it says, how can you tell whether a number is prime or composite? Well, let's look at the unlock the problem. Students are arranging square tables to make one larger rectangular table. The students want to have several ways to arrange the tables. Should they use 12 or 13 tables? And it says, what are the factors of 12? Well, let's figure out the factors of 12. So we know 1 and 12 is, right? So 1 and 12 is 2 a factor of 12? But, well, 12 is even, so I'm certain it is. 2, 4, 6, 8, 10, 12. So that was 2 rows of 6. So 2 and 6. How about 3? Well, 1 plus 2 is 3. And 3 can be divided by 3. So it should work. 3, 6, 9, 12. So 3 rows of 4. All right, so 3 and 4. 4 works? Yeah, we just did it. 5? No, because 12 doesn't end in a 0 or 5. 6 we already have. 7 will not work. 7, 14. 8, 16. 9, 18. And 10, 20. So, all right, so those are the factors of 2. Of 12. Now let's do 13. Well, okay, so we know 1 row of 13 would work. Or 13 rows of 1. 2 won't work because 13 is not even. 3, 1 plus 3 is 4. 4 is not divisible by 3. 4, no, because 13 is not even. 5, no, it doesn't end in a 5 or 0. 6 times 2 is 12, so no. 7, 14, no, not 7. 8, 16, no. 9 and 18. Oh, that's not 13. 10 and 10 is 20. That must be it. Okay. So if we wanted to find out which one we would have more options with, it would have to be the 12 tables, because I have 3 different ways I can arrange them. So I guess I would go with 12 tables. And so this introduces us to the idea of prime and composite, because it says how knowing 12 or 13 are prime or composite could have helped you solve the problem above. Because knowing that 13 is prime, we would have known there was only one way to arrange that, because there was only 2 factors. Okay, knowing that 12 had more than 2 factors and that it was composite would help us know that it was going to have multiple ways of arranging the tables. So let's look at the definitions. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. So why has it got to be greater than 1? Well, let's look at that. What is the factors of 1? Well, the only factor of 1 is 1. So that's why it has to be greater than 1. If we go to 2, well, we see that 1 and 2 are factors of 2, right? So a prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. Okay. So 1 is what we call neither prime or composite, because it only has 1 factor. A composite number is a whole number greater than 1 that has more than 2 factors. For instance, 4. Well, we know 1 and 4, but it also is 2 times 2. So this has more than 2 factors. So any number that has more than 2 factors is composite. Any number that has only two factors or exactly two factors, that's a prime number. So now let's list the factors of 12. So we did that in the grid. Okay. 1, 2, 3, 4, 6, and 12. And then the factors of 13, we listed as 1 and 13. So 12, since it has more than two factors, is a composite number. And the fact that 13 has exactly two, it is a prime number. Okay, so we're going to kind of use our divisibility rules that we practiced earlier to help us with this. Okay, so we're going to use the divisibility rules to help tell whether a number is prime or composite. If a number is divisible by any number other than 1 and itself, the number has to be composite. Okay, so tell whether 51 is prime or composite. Is it divisible by 2? No. Is it divisible by 3? Well, the divisibility rules for 3 say that if you add the sum of the digits up, and if it's divisible by 3, then that number is divisible by 3. 5 plus 1 equals 6. 6 divided by 3 is 2. So 51 is divisible by 3. So if 51 is divisible by 3, it has more than two factors. It's composite. Okay, because I know it has to already, 51 has to have 1 and 51 right now. And if 3 will work, then that's at least 3 factors. So it has to be composite. Use the grid to model the factors of 18. Tell whether 18 is prime or composite. So I'll just discuss this first before drawing it. I know this is going to be composite because it's greater than 2, or greater than 1. Any whole number greater than 1 that has more than 1 and 18 as it has factors of 1 and itself has to be composite. I know 2 is going to go into 18 because 18 is even. But let's go ahead and work it out. So we have one row of 18. Okay. One row of 18. And then as I said, I know 2 will work. So 2, 4, 6, 8, 10, 12, 14, 16, 18. I also know 3 will work because 1 plus 8 is 9, and 9 can be divided by 3. So I know we can go also rows of 3. 3, 6, 9, 12, 15, 18. Okay. 4 will not work because I would just count by 4s and go 4, 8, 12, 16, 20. I don't say 18 when I do that. 5, no, because 18 doesn't end in a 5 or a 0. 6, yes, we already identified that 6 is a factor. 7, we can just skip count by 7. 7, 14, 21, no, I didn't say 18. 9, 8, 8, 16, 24, I didn't say 18. 9 we already have as a factor, and 10 times 2 is 20, so 10 won't work. So these are our factors of 18. So the factors are 1, 2, 3, 6, 9, and 18. Do we have more than 2 factors? Of course we do. So 18 is composite. Okay, now 11. Tell whether each of these numbers is prime or composite. So we're going to run through our divisibility rules 1 through 9. Okay, we know 1 and 11 works. Okay, but we just got to find if there's one other factor. If there's just even one other factor, then it's composite. 2, no, because that's not even. 3, 1 plus 1 is 2. 2 can't be divided by 3, so 3 won't work. 4, 4, 8, 12. 4 will not work. 5 I know won't work because it doesn't end in a 0 or a 5. 6 will not work. 1 because 2 and 3 didn't work, but 6, 12, 18. So no, 6 won't work. 7, 14, no. 8, 16, 9, 18. So no, those are the only two factors. So this number is prime. Okay, number 3. 73. So again, we know 1 in 73. If there is at least one other factor than 1 in 73, it's a composite number. 2 will not work because it's not an even number. 3, 7 plus 3 is 10. 10 is not divisible by 3, so 3 will not work. 4. 4 times 20 is 80. 4 times 10 is 40. So 4 times 15 is 60. 64, 68, 72, 76. I didn't say 73 when I counted by 4s. 5s, no, clearly no, because it doesn't end in a 5 or a 0. 6, no, I don't have to do any tests for 6 because 2 and 3 didn't work. 7 times 10 is 70. If I add another 7, I get to 77. So not 7. 8. 8 times 9 is 72, so no way 8 will work. 9, I just eliminated that too because I said 9 times 8. And 10's not going to work. 10 times 7 is the closest I can get. And I don't have to go past 10 as far as checking for will they work because these are 2-digit numbers. And if I multiply two-digit numbers like 10 times 10, the smallest has to be 100. So it has to be a single factor. So I can actually stop at 9 for most of these. Okay, so 73, prime. 69. Well, we know 1 in 69 works. Will 2 work? No, 69 is not even. Will 3 work? Well, what's 6 plus 9? 6 plus 9 is 15. Can 15 be divided by 3? Yes. So this is composite. I don't have to list all the factors of the number. I just have to find out if it has 2 or more. Okay, and since as soon as I found out it has a 3, we can move on. 3 will work. Okay, 42. We know 1 in 42 works. Will 2 work? Yes, it's an even number. I can stop. It's composite. Okay, and if we want, we can just go ahead and list 1, 2, 42, so on. Okay, 1, 3, 69, so on. All right, number 6. Again, tell whether these numbers are prime or composite. 18, we actually did that on the previous page, but we know 1 and 18 work. We also know 2 works because 18 is even. So that's at least 3 factors. So it's got to be composite. 49. Well, I know 1 in 49 works. 2 doesn't because it's not even. 3, 9 plus 4 is 13. 13 is not divisible by 3. 4 does not work. 4 times 10 is 40, 44, 48, 52. So 4 won't work. 5 won't work because that doesn't end in a 5 or a 0. 6 times 8 is 48. So 6 won't work. 7 works. 7 times 7. So that's composite. 8 won't work. 8 times 6 is 48. 9 times 5 is 45, so 9 is not going to work. All right, so we can stop there. 29. We know 1 in 29. 2 won't work. It's not an even number. 3. 9 plus 2 is 11. 11 can't be divided by 3. 4. 4, 8, 12, 16, 20, 24, 28, 32. Nope, I did not say 29 when I was counting by 4s. 5, no, because it doesn't end in 0 or a 5. 6 times 5 is 30. So no, we're not going to say 29 when we count by 6s. 7, no. because we said 7 times 4 is 28. 8, 16, 24, 32. No. 9, 18, 27. No. 10 times 3 is 30. That's it then. So those are the only two factors. We're going to call this one prime. Okay, exactly two factors, 1 and 29. 64. That's an easy one, right? You should quickly say composite. Why quickly? Well, 1 and 64, right? Any number has 1 and another number, as long as it's bigger than 1, has itself plus 1 as a factor. And I also know 2 goes into this because it's an even number. So as soon as I know that there's more than 2, it's a composite factor, composite number. 33. Well, I know 1 and 33 work. 2 doesn't because 33 is not even. Does 3 work? What's 3 plus 3? 3 plus 3 equals 6. Is 6 divisible by 3? Of course it is. So this is composite. In fact, it's 3 and 11. Right? 3 times 11 is 33. 89. Well, I know 1 and 89. So let's see if there's any other factors. 2? No, because 89 is not even, right? 3. 9 and 8 is 17. Can 17 be divided by 3? No. 3, 6, 9, 12, 15, 18. So no. 3 won't work. 4. No, because 89 is not, it's not an even number. 4 is not going to work. 5, no, because it doesn't end in a 5 or a 0. 6, no, because 2 and 3 didn't work. 7 times 10 is 70. 77, 84, 91. No, 7 didn't work. 8 times 10 is 80. 11 times 8 is 88. So no, if I add another 8, I'm going to be over 88. It'll be 96, so no. 9 times 9 is 81. If I add another 9, that's 90. Okay, so no, this one's prime. It just has 1 and 89. 52, quick, composite. 1, 2, and 52 at least. 52 is even. 2's got to be a factor of it. 76, composite. Has to have 1, 2, and at least 76. All right, now true or false. Explain or give an example to support your answer. Only odd numbers are prime numbers. Well, if you get in a hurry, you might say, oh yeah, 3 is prime. And when I look at some of these other ones, 73 was prime, 11 was prime, 89 was prime. But this is false. Because 2 is prime. Only 2 factors of 2 are 2 and 1. Okay. 15. A composite number cannot have 3 factors. Sure it can. Look at 4. 4 has 3. 1, 2, 4. 9 has 3. 1, 3, 9. Okay. So that's a false statement. Oh, I guess I should say that. False. Okay. 16. I am a number between 60 and 100. My 1's digit is 2 less than my 10's digit. I'm a prime number. What number am I? Okay, so there's a bunch of big clues here. I'm between 60 and 100. So that tells me a lot of possibilities for the 10s. I can only be a 70, an 80, or a 90. I only have 3 possibilities. I have to be Oh, I could be 60. I'm sorry. I could be 60. I could be 61, 62, so on. Okay. Okay. So those are the only possibilities for a number in the tens between 60 and 100. Okay. So I can have a number that's 61 to 99. 61 to 99 are my possibilities. But then it gives me another huge clue. It says one digit is 2 less than my tens. My ones digit is 2 less than my tens. So what's 2 less than 4? 2 less than 6 is 4. What's 2 less than 7? 5. What's 2 less than 8? 6. What's 2 less than 9? 7. Okay, well, so now we're down to just these choices: 64, 75, 86, or 97. There should be some obvious ones that you look at and say, nope, that's composite. It can't be a prime number. 64. Why can't that be prime? Because it's an even number. So I know 1, 2, and 64 at least work. So it has more than 2. 75. I know 75 is not going to work because it ends in a 5. So it has to have 5 as a factor as well. So it's going to have 1, 5, and at least 75 as factors. 86. 86 is not prime. 1, 2, and at least 86 because 86 is even. Well, that only leaves me one choice: 97. So 97 is my number. Okay. All right, so now 17. Name a 2-digit odd number that is prime. Name a 2-digit odd number that is composite. Okay, well, 11 is prime. The only factors of 11 are 1 and 11. So now a 2-digit odd number that's composite. Well, how about 15? 15 is composite. 15, 1 and 15, 3 and 5. All right. And 18. Choose the words that correctly complete the sentence. The number 9 is, well, the factors of 9 are 1, 3, 9. So it can't be prime. So that composite has to be the answer because it has more than 2 factors. Again, if there's exactly 2 factors, prime. Anything more than 2 factors, composite. All right, and then let's finish up on page 222. The sieve of Eratosthenes. Okay. Eratosthenes was a Greek mathematician who lived more than 2,200 years ago. He invented a method of finding prime numbers, which is now called the sieve of Eratosthenes. Eratosthenes. Sounds good to me. I'm not Greek. Eratosthenes. Follow the steps below to circle all the prime numbers less than 100. Okay, so he came up with a strategy for us to figure out prime numbers. Well, that's kind of helpful. All right. Cross out 1, since 1 is not prime. That's true. Okay, so let's cross out 1. Okay, 1 is neither prime or composite. 2, circle 2, since it is prime. Cross out all the other multiples of 2. Oh, that would make sense because 2 is going to be a factor of that multiple plus whatever, like 1 and that multiple. So Cross out all the other multiples. So 4 is not prime because it has factors of 1, 2, and 4. Okay. 6. Okay, so we're just finding multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So basically what we're doing, we're eliminating the second column because those are all even numbers, which means they're all multiples of 2. And if 2 is a factor of the number, it cannot be prime if the number is greater than 2. All right. Oh, we eliminated a lot. Okay, so now circle the next number that is not crossed out. 3. The only factors of 3 are 3 and 1. Okay, so 3 and 1. Now, cross out all the multiples of that number. Okay, for the same reason. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60. So all I'm doing in my head is counting by threes, right? 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. Okay, so we eliminated a lot more. Okay, and then he says, repeat step 3 until every number is either circled or crossed out. All right, well, the next number that's not crossed out or circled is 5. 5 is prime, just 5 times 1. So now we need to cross out the multiples of 5. 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. All right. Now circle the next number that is not crossed out or circled. All right, so now we're looking for the multiples of 7. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91. Okay, let's go 11. We said 11 is prime. So now we need multiples of 11. 11, 22, 33, 44, 55, 66, 77, 88, 99. All right. 13, 26. 26 and 13 is 39. 39 and 13 is 52. 52 and 13 is 65. 65 and 13 is 78. 78 and 13 is 91. Okay. Next, 17. 17 plus 17 is 34. 34 plus 17 is 51. 51 plus 17 is 68. 68 plus 17 is 95. All right. 19. 19, 38. 19 plus 19 is 38. 38 plus 19 is 57. 57 plus 19 is 76. 76 plus 19 is 95. Okay. Now we move 23. 23 plus 23 is 46. 46 plus 23 is 69. 69 plus 23 is 92. Okay. 29. 29 plus 29 is 58. 58 plus 29, let's say we don't know that. 59 plus 20, 58 plus 29, 17, 87. 87 is crossed out. So, all right. Now we move to 31. 31 and 31 is 62. 62 and 31 is 93. Already crossed out. All right, let's go to 37. 37 and 37 is 74. Already crossed out. 74 plus 30, that's going to be over 100, so I'm done there. 41. 41 and 41 is 82. 82 is already crossed out. 43. 43 plus 43 is 86. It's already crossed out. 47 and 47, 94. It's already crossed out. 53. Well, now none of these can be multiples as far as up to 100. So 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Those are all prime numbers. So the prime numbers less than 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So 25 prime numbers out of 100 numbers. Okay. Now 20. So the whole purpose of that idea, explain why the multiples of any other number other than 1 are not prime numbers. Well, a multiple of a number multiple of a number has more factors than 1 and itself. Okay. So that's it for the concept of prime and composite numbers. Tomorrow we'll be working on number patterns, which can be fun. So until then, may the numbers always be in your favor.